This is 4.6, solving inequalities using multiplication or division. So we have multiplication and division properties of inequality, and the first case says that when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So we're going to look at a few examples of this, and if we have x over 4 is greater than or equal to negative 12, I need to get x by itself. So this over 4 represents division, and so we need to multiply to undo that division. And when I multiply each side by 4, I get x is greater than or equal to negative 48. And then when I graph it, I have a filled-in circle, and x is greater than, so I shade the numbers greater than 48. Over here we have 8/3 is greater than y over 9, and again this represents division, so we need to multiply on each side to get y by itself. Then we have 72 over 3, which reduces to 24 is greater than y. This has an open circle because it is just a greater than, not equals to, and y is less than, so we shade the numbers less than y, or less than 24. Then we have x divided by 1.5 is less than 30. The opposite of dividing is multiplying. So when we multiply 1.5 times 30, we get 45. This will have an open circle, and x is less than, so we shade the numbers less than 45. Over here we have 6 is less than or equal to 3/5 x. We need to divide by a fraction, and the way we do that is to multiply by the reciprocal. So you flip the fraction and multiply on each side, giving 30 over 3, which reduces to 10, is less than or equal to x. This has a filled-in circle because it is or equals to, and then x is greater than, so we shade the numbers greater than 10. 15x is less than 75. We need to divide by 15 to do the opposite of multiplying, and then we have x is less than 5. This gets an open circle and shaded to the left. Negative 15 is less than or equal to 2.5y. Divide each side by 2.5, and negative 6 is less than y, meaning y is greater than negative 6, so we shade the greater numbers than 6. We have 4.5 is greater than or equal to 10x, so to undo this multiplying by 10, we need to divide by 10, and then we get 0.45 is greater than or equal to x, and that gets a shaded in circle and shaded to the left. Then we have 7/5 is greater than 3/4 x. Again, we need to divide by the fraction, so we multiply each side by the reciprocal, and we get 28 over 15 is greater than x. And then this gets an open circle shaded to the left because x is less than. Case 2 talks about when we have multiplication or division properties when we are multiplying with a negative number. And when we multiply or divide by a negative number, we need to reverse the sign or reverse the way our inequality symbol is facing. So if a is less than b and c is negative, then if I multiply each side by a negative number, the sign switches direction. Or if I divide by a negative number, the sign will switch direction. So here we have negative 2/3 x is less than or equal to 12. To divide by the fraction, multiply by the reciprocal. And in multiplying by a negative 3/2, it makes the symbol switch directions, so now it is x is greater than or equal to negative 18. And then my graph will be solid, and x is greater, so it goes to the right. Then I have negative 0.5 is greater than x over negative 12, and to get rid of this dividing by negative 12, we need to multiply each side by negative 12. And in multiplying by a negative number, it switches from a greater than to a less than. So now x is greater than 6, and we have that shown here. if I have 16 is less than 12 over 5y, again, to divide by a fraction, you multiply by the reciprocal, and we get 20 over 3 is less than y. So our graph shows y is greater, so it goes to the right. Negative 3.5 times y is greater than or equal to negative 31.5. So then we need to divide by negative 3.5 on each side, and since it's a negative number, it switches from a greater than to a less than. So y is less than 9, so we shade to the left. This last one says a submersible descends in a lake at a rate of 32.8 meters per second. The bottom of the lake is 210 meters deep. What is the minimum amount of time it takes for the submersible to reach the bottom of the lake at this rate? So, if I draw out what is happening, I have starting at the surface and then going down 210 feet, so that means it is a negative 210. And it's moving at a speed that is descending, so it's going down, or negative, at 32.8 meters per second. So I can make my inequality negative 32.8 multiplied by x, and x represents the number of seconds that it takes for it to reach the bottom. So 32.8 for every second must be greater than or equal to negative 210, because it said what is the minimum for it to reach this depth, so it must be faster than that. So to get x by itself, we divide by negative 32.8 on each side, and x is less than or equal to 6.4 seconds, because it had to switch sides.